So there are three different types of probability. On that formula there on the top of the page, I wrote experimental probability, but that formula will actually work both if it's experimental or theoretical. So the third type is simulation. So what all that means, experimental means you actually perform the event. So like if I said, what's the experimental probability of flipping a quarter 5 times and it land on heads all 5 times, you would go and actually do that. You would perform the experiment. Theoretical probability is what's supposed to happen. So supposed to, you got a 1 out of 2 chance of landing on heads. So that's what's supposed to happen theoretically. And then simulation probability, we won't do much of that. But I don't know if you've messed around on the calculators. Some of the TI-84s have a probability simulator in there. They've got a little spinner that you can mess around with, but we won't do much of that.
We are now having a fire drill. Please follow procedure.
Out the back, no, I didn't. Out the back door. I didn't know. Zach, you can be a flag man. This video will resume after the fire drill. Good job, Zach. I asked Tyler and Christian, and he said, I think we're supposed to get calls. And I said, it says on this email 8:55. So I just sent them. Okay, we all made it back safely from the fire, so glad you're still here.
Except for a kid in the bathroom.
Except for the kid in the bathroom, that's right. Alright, so we said experimental probability is when you actually do it. Theoretically, it's what's supposed to happen, and then simulation we won't mess with much. So the probability is always written with a P and then in parentheses whatever you're looking for. So when you see a P, you know you're dealing with probability. So the number of times it happens over the total. That's how you find your probability. That's your formula for you there. So let's do one real quick. One page turn for me. Can't get my pager. There we go. Alright, so let's say that there are 60 vehicles in the parking lot. Need a marker. 60 vehicles in the parking lot. 15 of them are pickup trucks. What's the probability that a vehicle in the parking lot is a pickup truck? So you would write probability of a pickup truck. I'm just writing truck. So how many pickup trucks were there? 15. How many total vehicles in the parking lot? 60. Reduce if you can. So that would reduce. You can take a 15 out of both of those. Now, the way to say a probability, you can say it lots of different ways. You can say there's a 1 in 4 chance. You could say that is a 25% chance. So that's all correct. I think around this part of the world, it would be a higher probability of finding a pickup truck.
Yeah.
In the redneck world here. Alright, let's do another. Let's use a couple of these practice ones. So theoretically now, we're not actually going to perform this experiment. It says what is the theoretical probability of getting a 5? So I'm gonna say probability of getting a 5 when I roll a number cube. And by the way, tests have gone back and forth, like ACT tests and all that, on whether or not they can use the word dice or number cube. At one point, they made them all take dice out because they thought that promoted gambling. I guess they don't play Monopoly or Yahtzee or anything, I don't know. So if you say number cube, that just means a normal dice. Or die, whichever one it is. Alright, so how many 5s are there on a number cube? Just one, so you got a 1 out of. How many numbers are there on a number cube? 6. So you got a 1 in 6 chance of rolling a 5.
Teachers, please release the band students to the band room at this time.
Get it together in that office. Okay, so same number cube now. I want to know what's the probability of rolling a sum of 5. If I roll, I got 2 number cubes. If I roll 2 number cubes, what's the probability of rolling a sum of 5? Okay, so let's write down what all we have on our number cube. We got a 1, a 2, a 3, a 4, a 5, and a 6. But we got 2 number cubes, so we have that same thing again, don't we? Okay, so how many ways can I get a sum of 5? Well, let's just start looking at some. I could do, there's 1. I'm going to make some tally marks up here as we find them. There's 2. There's 3. Oh, I'm about right here. There's 4. Is that it? Is there any other sums of 5 that I didn't underline? Y'all good with that? So 4 out of, now how many different, need an equal sign there, how many different ways could that number cube have landed? And this attaches to what we did yesterday. Could have landed 6 different ways on the first one and 6 different ways on the second one. So that fundamental counting principle, you just multiply those. So, whoops, 6 times 6, so that would make a 36. That'll reduce, divide them both by 4, and you got a 1 in 9 chance of rolling a sum of 5. And that'd be, isn't there some things kind of similar to that on Yahtzee? Some weird things like that? I haven't played it in a long time. Alrighty. Let's do one more that has geometric probability. That's another kind of probability I didn't tell you about a minute ago. Geometric probability. Draw a couple of rectangles here. So, I don't know what that is. Let's do that one. Oh, let's do that one. Oh, let's do that one.
This is geometric probability.
Yes. And what you'll know is that it's got shapes. It's pretty deep, isn't it? Okay, so geometric probability, you know, the big, like, that's common sense, the bigger the area, the bigger your chances are of hitting it, whatever. You'll see a lot of these with a dart game, the bullseye. What's the probability of hitting in the center of the bullseye and all that type of stuff. This problem that we got here, that big square, that's, or big rectangle, excuse me, that's the batter's strike zone. Okay, I've got a picture of the guy batting, and that goes from the bottom of his arm to his knees there. And so they're giving me that this is 17 inches across, and it is 22 inches tall. Okay, so a batter's strike zone depends on the height of the stance of the batter. What's the geometric probability that a baseball thrown at random within the batter's strike zone, as shown, will be a high inside strike, one of the hardest pitches to hit? And so they're giving you this little area as the high inside strike, and it is a 4 inch by 6 inch. Okay, so your probability of this, probability of high inside, I'm just going to write high. Your probability of this is going to be the same as the other stuff. It'll be what you're looking for, so it'll be the small area here. So how could we describe this as a formula? The geometric probability, so you got it in, Holly wants to get it in her notes. desired area maybe, would that sound good, Lucky? Or OBALIT, so the desired area, the area of what you're looking for, DESIRE, you know, I'm a horrible speller. Still over total, but it'll be the total area. Okay, so our desired area here, we're trying to hit that high inside zone there, so area of a rectangle is just length times width, so 6 times 4, so that's 24. The whole thing, the big rectangle, 17 by 22. So let's figure out what 17 times 22 is.
374.
Thank you. And then we would reduce that if we can. I don't know if that'll reduce or not. Just tell me, divide it. Tell me the percentage. Do 24 divided by 374.
0.064.
So that would mean, to make that a percentage, the pitcher has just about a 6% chance of hitting that zone. In reference to the whole area. So it's a much smaller piece in there, so you know, they could have like halved it instead of low ball or a high ball, but they put it up there in that little bitty corner. And you'll see that, like I said, with bullseyes a lot, that type of problem. Oh, there is a bullseye one right there. I wonder why I didn't pick it. Must not have seen it. Alright, everybody alright on that? Pretty easy stuff. I didn't want to do too much for the band people that are going to have to play catch up. But the next lesson that we'll look at on Thursday is the probability of multiple things happening. So if you think back to the dice rolling thing, what's the probability that one of them is a 6 and the other one's a 4? So that starts getting a little bit more complicated when you get into more than one thing happening. Alrighty? Alright. Easy schmeezy. Even had a fire drill.